Hi class, in this lecture we continue our study in chapter 6 by moving into section 6.6. And this is factoring special binomials, okay, so two-term binomials, so special cases that come up, and then finally a factor strategy for factoring much harder polynomials. Okay, so the first special factoring method is what we call the difference of two squares. So if you have a quantity squared, a squared, minus a quantity b, b squared, this will always factor into just whatever the a is plus b multiplied by the a minus b. So in words, the difference of the square of two terms is the product of the sum of the terms and the difference of the terms. Okay, so the trick here is identifying what a is and what b is. All right, so in general, except for factoring out the GCF, a sum of squares cannot be factored. So if you see something like a squared plus b squared, that you cannot factor sums. You can only factor the difference of two squares. All right, so let's look at this one. So here I have 4x cubed minus 36x. All right, well, the first thing you're going to notice, you want to factor out the GCF of this. Okay, if you factor out the GCF, you realize that that's GCF is 4x. You're going to get the following. Okay, so you get 4x times x squared minus 9. So the trick here is to look at, hey, well, look, I have something squared minus, hey, is 9 a square? Okay, well, yes, it is 3 squared, right? So you have x squared minus 3 squared. So basically that's the a squared minus the b squared. So it becomes a plus b, so a plus 3 times a minus 3. So the trick here was looking at this and realizing that it's this right here. Okay, because 9 can be rewritten as 3 squared. All right, let's try this one. Now this is weird, okay? So 16p to the fourth minus 1. Well, the binomial 16p to the 4 minus 1 is actually the difference of squares, believe it or not. I can rewrite this as 16p to the fourth is the same thing as 4p squared squared. And obviously 1 is the same thing as 1 squared. So this will factor into a plus b, so 4p squared plus 1, times a minus b, or 4p squared minus 1. Now the trick is then to recognize that this right here, this second part, is also the difference of squares, so you can keep going. Like this is 2p squared minus 1 squared. So then this would factor into 2p plus 1 times 2p minus 1. And you can verify this by plugging values in your calculator and seeing that they are actually equivalent statements. This 4x squared is the same thing as what we just factored as here. You can also have the sum or difference of cubes, and this is just straight up following the formula. So if you have a cubed plus b cubed, that will immediately factor into a plus b times a squared minus ab plus b squared. A cubed minus b cubed, well, that will factor into a minus b, and then times a squared plus ab plus b squared. All right, so let's look at this one right here. X cubed plus 8. I immediately recognize that my x is the value of a, and 8, believe it or not, is actually 2 cubed. So you can see straight up, I'm just going to plug it right into the formula. My a is equal to x, my b is equal to 2. Plugging them right in, you can see that this will factor into then x plus 2 times a squared, okay, which is x squared, minus a times b, which is minus x times 2, plus b squared, which is 2 squared. And just cleaning this up, minus x times 2 is minus 2x, and b squared gets you 4. So this right here is just straight following the formula, just straight up following it. All right, so we look at this trinomial here. We know that that is prime because there's no two numbers that multiply to 4 and sum to negative 2. So we've now factored this completely. We can't go anymore. And you can verify this again by plugging the two values in your calculator and looking at test points. Let's try this one. This looks like the difference of two cubes. All right, so I'm going to recognize that x cubed is, x cubed. 125 is actually 5 cubed. It's 5 times 5 is 25 times another 5 is 125. So this will immediately factor into, right, because it's the difference of cubes. A minus b, or x minus 5, times a squared, which is x squared, plus a times b, x times 5, plus 5 squared, b squared here, which is the 5 squared. So this cleans up as just x squared plus 5x plus 25. So we know that that is also prime. So we've completely factored this. We're good. All right, let's try this one. This one's very crazy. All right, so this right here, n to the 6 minus p to the 6. First off, I'm going to recognize that n to the 6 is the same thing as n cubed squared and p cubed, or p to the 6 is p cubed squared. So this factors as the difference of two squares. Okay, so it becomes, it becomes n to the third plus p to the third times n to the third minus p to the third. And then this just factors literally as the sum of cubes, and all I'm doing is changing the a to the n and the b to the p, and this factors as the difference of two cubes as such. So a lot going on that one. All right, so these are some steps for factoring here. All right, these 5 steps that follow can be used to factor many polynomials. So steps 2 to 4 can be applied to the entire polynomial or just to a factor of the polynomial. So first off, if the leading coefficient is positive and the GCF is not 1, obviously we factor out the GCF. If the leading coefficient is negative, you factor out the negative, so you factor out the opposite of the GCF. All right, for a binomial, try using one of the properties for the difference of two squares, the sum of two cubes, or the difference of two cubes. All right, so for those binomials, try some of the special factoring methods. For a trinomial of this form, ax squared plus bx plus c, all right, if a is equal to 1, then all you're going to do is try to find two integers whose product is c and whose sum is b. All right, you're just going to play a simple number game. If a is not equal to 1, you're going to use the methods I talked about in the previous section. So try factoring by trial and error or by grouping. And then, all right, if you have a polynomial with 4 terms, obviously try factor by grouping. And then all you're going to do is continue steps 2 through 5 until the polynomial is completely factored. Okay, so you cannot factor it anymore, no more. All right, let's try this one, this crazy one here. X to the 4th minus 2x cubed plus 1000x minus 2000. All right, since the polynomial has 4 terms, try to factor it by grouping. So you're going to group the first 2 terms together. You're going to factor out an x cubed. You're going to group the second 2 terms together. You're going to factor out 1000. So here you get, you see that the common factor is x minus 2, so I'm going to factor that out. And now you're going to ask yourself, is this the sum of cubes? Well, indeed, 1000 is 10 cubed, so you're just going to apply this as x plus 10 times x squared minus 10x plus 100, factoring it simply as the sum of 2 cubes. And this right here, this crazy product here, is this fully factored. Let's try this one here. Factor 50t squared w squared minus 8w. So start with the GCF. Okay, so for this polynomial, the GCF is 2w squared. So I'm going to factor that out. And then once I factor 2w squared out of this, I get 25t squared minus 4w squared, which looks like the difference of two squares. So this is 5t squared minus 2w squared. All right, so because this factor has 2 terms, we check to see whether it's a difference of 2 squares, which it is. So we can now factor this as 2w squared times 5t plus 2w times 5t minus 2w. So these just involved a lot of checking and see if you can go further and further. And the more you practice on the homework, the easier this will get.